Hey folks, Mr. Kowalchuk here. So I'm just going to spend some time working on Brian Passwater's 3.3 curriculum. This is the second half of it. Yesterday we did the first part. So in this particular case, what we're going to do is we're going to start out with considering the unit circle labeled above. So just try to discount all the stuff outside of here. That purple stuff is from the other problem we did yesterday. Find the values of the following. So in this particular case, we're asked to solve for the cosine of 0 radians. You can see pi over 2, pi, and 3 pi over 2. They're all in radians, and we've got the sine here as well. So in this particular case, just a reminder, we know that the cosine of any particular angle on the unit circle is equal to the x value, and the sine of that same angle is equal to the y value. So here we see that we've got x and y values for each of the four corners on the x and y axes. So we can go ahead and do that. Using this rule, cosine of theta is equal to x tells us that the cosine of 0 is equal to 1 because that's the x coordinate right here at 0 degrees. Cosine of pi over 2 is the x coordinate here at pi over 2 radians. So that's why the cosine of pi over 2 is 0. Same thing coming over here at pi, because we go halfway around the circle, that's going to be pi radians. Our x value is -1. And then also for 3 pi over 2, that gives us an x value right here of 0 as well. So we see that pattern of 1, 0, -1, 0. Now for the sine, we're going to use the y values at those particular radians. So here, for the sine of 0 radians, we're going to be, our y value is 0, so that's going to be 0 there. At pi over 2 radians, we come up to here, our y value is 1. At 1 pi radians, our y value is 0. And at 3 pi over 2 radians right here, our y value is -1. So we see how that pattern shifts: 1, 0, -1, 0, 0, 1, 0, and -1. This implies that the sine and cosine functions are periodic and they're horizontal shifts of each other by pi over 2. All right, let's flip on over to the next page here. Okay, so finding sine and cosine function values. So this is going to be a little bit different than what we did on block day. And in this particular case, what we're going to be doing is finding numerical values for functions involving sine and cosine at important angle values, right? We've talked about a lot of those important angle values on our unit circle, so we know what those are. The angles that we've been working on involve multiples of pi over 4 and pi over 6, right? So pi over 6 can also include pi over 3. So we can just reduce that pi over 6 fraction sometimes to get to a pi over 3. Okay, so moving down a little bit here, what that tells us is that we've got this idea of a unit circle. So we have our circle centered on the origin, we have a radius of 1, and we know that this is going to be 1/2 unit high. So if we know this, it shows pi over 6 because we know that our first value of 1/2 is going to be pi over 6. So this angle here is going to be pi over 6. And then down here, this would be a negative. Theta here would be equal to a negative pi over 6, just to check that out. Remember, negatives go clockwise. Now what we can do here is we can use the Pythagorean theorem with this right triangle, and I'm just going to highlight that right triangle that we're going to focus on here in yellow. So if we look at this right triangle here, let's say we didn't know what the x value was. In this case we do, but let's just say we didn't. We could use our Pythagorean theorem to solve for the x value coming over here from the origin. So again, a squared plus b squared equals c squared, where c is our hypotenuse. So then we would have 1/2 squared plus b squared equals 1 squared. So 1/4 equals b squared, plus b squared equals 1. B squared equals 3/4, and that gives us a b when we square root both sides equal to the square root of 3 over 2. 2 is the square root of 4. Okay, so we can find those values, which is our b value, and we know that the pi over 6 is √3 over 2 comma 1/2, but this is just an example to show you that we can use that Pythagorean theorem with any circle where the radius might not be 1, or we might not be familiar with what our coordinate points are. Okay, So this just reinforces our cosine and our sine are going to be our x and our y values at that particular angle, showing that the cosine at pi over 6 is root 3 over 2, and that the sine at pi over 6 is 1/2. That's the x value, and that's the y value. Okay. All right. Let's skip on over to the next page here. So here, for example, 4, what we've got is the figure shows a unit circle, radius of 1, centered on the origin. That's a unit circle. And we got triangles QRO and PSO. So QRO and PSO. Inscribed, meaning the vertices are on the triangle. Excuse me, on the circle. Use the symmetry of the unit circle to find the coordinates and measures for the points Q, R, and S. Now, we've done this quite a bit already. We have reflected points back and forth, so we're just going to continue to do that now. We know that these are going to be similar, same triangles. So when we reflect over this axis here, we go from positive x, positive y. We go to negative x, negative root 3 over 2, comma, positive y, 1/2. Same thing down here. We're going to reflect over that x-axis. So we're going to have a negative and a negative. Negative root 3 over 2, comma, negative 1/2. So we're looking at these for the points. So for point Q, again, we got negative root 3 over 2, comma, 1/2. And then for R, we have negative root 3 over 2, comma, negative 1/2. And for S, we're going to have a positive x root 3 over 2 and a negative 1/2 y value. Okay. So now the next thing we're asked to do is to find the angle measure. You could do this on your unit circle, or you could try to remember which ones come here. I'm going to let you do that on your own and try to figure out what angles go there in these locations to point Q, Q, R, and S. Okay. Same process for pi over 4. Again, we've done this before. So this is going to reflect over here. We're going to get a negative and a positive. We reflect down here. We're going to get a negative and a negative. We reflect over here. We're going to get a positive and a negative. Okay. So fill in your coordinates and also fill in those angle measures. Again, pi over 4 reflects over here, down to here, and down to there. What's that going to look like when you go through that? Okay. All right. So last page here. This is going to be, we did pi over 6. Now we're going to do pi over 4. Excuse me, pi over 4. And last we were going to do pi over 3. So we got pi over 3 and 1/2 comma root 3 over 2. Again, that's going to reflect over here, negative comma positive, down here, negative comma negative, over here, positive comma negative. So go ahead and fill those out and then practice your pi over 3 radians as well. Okay. Last little thing down here is going to be your cheat sheet for what that's going to look like, but hopefully you didn't get to that and you recognize that it was important to practice it up here. Last thing, folks, just a reminder that we are required to practice these. You do want to memorize this unit circle. It's going to really help you out. Okay. This last page here, I'm going to let you practice on and finish this up before you do your homework. We got all of our angles here. So what I'd like you to do is to label everything in radians. If you want to put the degrees in there, that's cool. Go all the way around the circle, just like we did on the quiz, and then put the points in there. See if you can do everything by heart without looking at your unit circle or the one on the previous page. Then once you're done with that, you're going to come down here and fill in all of the values for these particular functions, right? So let's just come down here real quick. We've already done cosine of pi. That's going to be our x value at pi. Coming up here, pi radians is all the way across. Our x value is -1. Okay, so that's just one example of how you would do that. Done a bunch of these before, but we have a lot of values in here that are going to be in the second, third, and fourth quadrants. So practice those values, plug them in, make sure you know what your x and y is for sine and cosine. All right, folks, thank you so much. Hope you have a great day, and the homework is posted in Schoology, so go ahead and finish that up. Thank you.